Good day, grade 9 science students. Today what we're learning about is something called chemistry. Now, this is your first flip classroom video. What that means is that you can rewatch this video. You should take short notes when you do this. The reason why we're doing it is it's going to make learning in class a lot more effective. You're going to be doing more hands-on things in class instead of just taking notes. Now here's the idea. Our first video is dealing with chemistry. I'm going to show you a series of pictures and I want you to see what do they share in common. Okay, we have an apple, we have an airplane, we have a tree, and we have a stone. Now what do they all share in common? Well, this isn't some sort of puzzle. It's not some sort of stone, tree, plane, apple combination. They are all made up of something called matter. Now chemistry is the study of matter. Okay, so what is matter? We're going to say matter is anything that has mass and volume. Mass is kind of the quantity of matter in an object. So certain objects that are very heavy, for example, have a lot of mass. That means they have a lot of matter. If I weigh more than you, and I probably do, that means I'm made up of more matter. Now, if matter is anything that has mass and volume, mass is the quantity of matter, and volume is the measure of how big an object is or how much space a fluid would take up in it. So it's really like the volume of it, the size of it, the space that it takes up. Now this is a theory, but we're very certain because we can actually see the surface of atoms. We're very certain of this theory, and it's known as the particle theory of matter. And it says that matter is made of tiny objects called particles that are too small to be seen. Now we can actually have the ability to see the outside of atoms at this current point, certain types of atoms. But when this theory they came up with this theory, they weren't even able to see atoms at all. Now, different substances are made up of different particles. So that means water is going to be made up of tiny little things that are different than gold is. Gold is going to be made up of something different as well. They have lots of spaces between these particles. So even though something is solid like this desk right in front of me, it actually has spaces between them. And you are made up of matter as well. You're made up of particles, tiny little things. There's spaces between them as well. These particles, even though we can't see it, are always moving. And the particles in each substance are attracted to each other. So with this last point, that means is that my hands coming together, there's actually a slight attraction between the particles in my left hand and the particles in my right hand. And there's actually an attraction between any types of particles, and they're just very, very weak. We can't feel them, except when they're very, very close together. So the three main phases of matter that we have, you should know already, are solid, liquid, and gas. And we can say, if you take a look here, the spaces between the particles is actually very small in a solid, and liquid is farther apart, and finally gas it's very far apart. Now all of these particles move. Solids move, they vibrate back and forth. Liquids, they slide past one another, and gases, they bounce off one another. And we can say that the attraction for gases, because they're so far apart, is very weak. But as we get to a solid, the attraction is very, very strong because those particles are so close together. When we talk about a shape of a solid thing like my phone here is not going to change its shape. It has definite shape. Now, if I had a liquid, like a glass of water, the water takes the shape of any container that I put it in. Now, a gas, like that's in this room that I'm talking to, it's actually taking up the entire space. It takes the shape of the room. If you release a little bit of gas in any shape, it's going to actually take that shape. Now, the volume of liquid, if you have 100 milliliters of water, you will have 100 milliliters of water always. It doesn't matter what container you put it in. If you have if this phone is 100 milliliters, it's going to take up 100 milliliters of volume always. Gas, on the other hand, it takes up the size of the container, and so therefore it has infinite different amounts of volume. Now, the ability to flow, it's known as does it move past one another? A solid does not flow. Like you can't pour it out of a container like you can water. Liquid will flow. A gas will also flow as well because it can move quickly and can move past one another. So grade 9s, this should be review for you as well. We can actually change the state of matter, and the way we do it is we add heat. Now, if you have a solid, the particles are very, very close together. If you add enough heat, you can actually cause it to melt, just like an ice cube. So as we add energy, we cause it to melt, okay? And if we add even more energy to a liquid, for example, we can actually turn it into a gas, which is known as vaporization or evaporation. So the lowest amount of energy is when it's solid. It gets more energy when it turns to a liquid, and then finally it turns to a gas where it has even less energy. Particles are very close together. They're farther apart in a liquid, and finally they're very, very far apart as a gas. So you can see here when we add energy, we go from something with a fixed volume and fixed shape, and it moves faster and faster and faster. And when it moves faster and faster and faster, it turns to a liquid. And then we add even more energy, it evaporates into a gas where it has lots of energy. Well, when we remove energy, the opposite. If you take a gas and you cool it, it will actually condense, which means it gets closer together. Condense means closer together, and it turns into a liquid. And if we remove even more energy from a liquid, like you take some, I don't know, water and put it in your freezer, you remove energy and it turns into a solid. The last type of change of state that you don't know about is known as, never heard of a solid going directly to a gas, or maybe you did in elementary school. This is known as sublimation. If you had dry ice, and I'll show you this one day for Science Friday, dry ice turns into a gas. It immediately turns from a solid to a gas. And the opposite direction we call crystallization. But sometimes they say that sublimation actually goes in both directions. So if matter is everything around us, scientists like to classify things, which means organize them into different structures. So here what we have is we have matter, and it can be divided into two main groups. The first group is going to be called pure things, or pure substances, and the second thing is called mixtures. We're going to define these in class, but mixtures are mixed up things, different things that are just mixed together, and pure things are considered to be pure, meaning that they're made up of one type of thing. So of the pure things that we have, we actually can have elements, which are found on the periodic table, and we can have compounds, which are combinations of elements. So for example, elements are anything on the periodic table. This is actually copper, okay? Goes by the element symbol Cu. And compounds are combinations of elements. For example, this is sugar, this is an exact formula for sugar, but this is a type of sugar. And it's made up of carbon, 6 carbons, hydrogen, 12 hydrogens, and 6 oxygens. It's a combination of different elements, but it's still pure because if we took these apart, we'd find little molecules, we call them, of these elements mixed together. Now mixtures, on the other hand, they actually are mixtures of different types of compounds, elements, and different things. And we have something known as a homogeneous mixture, which is just water. This is tea, so sugar and water would be mixed together. And you can't see the difference between the sugar and the water. I can't point directly and say, hey, that's just sugar, or hey, that's just water. I can't do that because it's mixed really well. It's a homogeneous mixture. Sometimes it's known as a solution because it's so well mixed. Heterogeneous mixtures, on the other hand, to the right of me right here, this is oil and this is water. And you can clearly point to the different sections. So when we say hetero, oftentimes we're meaning two things, and homogeneous means one thing. So heterogeneous means we have two different phases. So that's the end of today's lesson.